Hello everyone, today I'm going to introduce our work, Retrospective and Prospective Mix of Generators for Task-Oriented Dialogue Response Generation. This work is done by me with Pengjiu Ren, Christoph Mons, and Martin Derajek. Firstly, let's give a quick look at what is a dialogue response generation task in our work. Given a dialogue context as an input, which may include historical utterances, belief states, ritual results from a database, then the model should output a response, which consists of a sequence of words generated token by token. And this response should fulfill with the following two criteria. First, task completion. For example, it should assist a user to book a flight successfully. Second, language fluency. It should sound like a real natural language from a real person. The existing assumption from the recent work is that each token in a response is drawn from a single distribution over the vocabulary. However, we found this is unreasonable. We have done statistical studies on the dataset and find that relative token frequency distribution of different domains, different system actions vary greatly with different intents. To address this issue, we propose one-chair K-expert framework. In this framework, we assume we have K-expert generators, each of which is specialized for one particular intent. For example, one domain or one system action, and then we have a chair generator, which is able to learn to coordinate a group of experts to make an optimal decision. And here, specifically, we follow the sequence-to-sequence and an encoder-decoder architecture for each expert model. And in the decoder part, we use a mix of experts to adopt it to get a final optimization. This work, our main research question is that does the dialogue response generation performance improves if a response is drawn from a mixture of distributions rather than just one single distribution for a general intent? We have done a lot of experiments on the multi-voice datasets, which consists of about 10,000 natural conversations between a tourist and a clerk. And we study on two groups of intents, which are divided by domain and the system action. First, we have conducted automatic evaluation on the main resource. We have a blue value to evaluate how fluent the generated response compared with the golden response. And inform and success evaluates how successfully the model can provide important information. And the score is an overall balance between the language fluency and the task completion. So the overall performance of a MOGNET improved about 5.64% of a score compared with the state-of-art baselines, which balancing both the task completion and language fluency. How well our model improves compared with the baseline models. We have also conducted human evaluations on the Amazon Mechanical Turk platform. We randomly choose 100 context response pairs from two baseline models and also our models, and we devise three criteria for the workers to evaluate our responses. So informativeness provides how well the generated response provides with important information. Consistency evaluates how well the generated response is consistent with the golden response. And satisfactory is an overall feeling of the whole generated response, also considering both informativeness, consistency. Overall, our MOGNET improves more than 12.5 of the overall performance, manually evaluated by the satisfactory of the workers. And then we also have done some case studies on some specific examples. So let's give a quick look at the simple example and see how our model outperforms compared with the state-of-the-art baselines. Given a dialog context from user, I'm looking for a train departing from value place that will arrive at the value place. Then we have the responses generated by the three models as the red part. And compare with the two baseline models, we find MOGNIT can provide actual important information compared with the baselines. Here we have one more word time. And also compared with the second baseline, our MOGNIT can avoid redundant responses. So it's more briefly compared with the second baseline. And also, our model is not only dependent on the design of the framework, but also design of the coordination mechanisms and the learning scheme. So we done the application study to see how these two parts affect with the overall performance. So compared with the MOGNIT model, we remove the coordination mechanisms and find it decreases about 2.62% for overall performance. And when we remove learning scheme from the MOGNIT model, we find it decreases about 6.95% of overall score. Our two proposed coordination mechanisms and one learning scheme is so important for our framework. To conclude, in this work, we have three main contributions. First, we propose a mix of generator network model that firstly devises chair and expert generators for the dialog response generation task. Second, we propose two coordination mechanisms, retrospective and prospective generators to help the chair make better decisions. Last but not least, we designed a global local learning scheme to differentiate its experts and fuse data efficiently. In the future work, we're going to explore different coordination mechanisms between chair and the expert generators. And also, we can study on how to do the intended partition automatically. Thank you for your attention. If you are interested in our work or want to discuss more details with me, please contact me by forwarding emails, and also can get our code from my personal GitHub page. Thank you.